In the next set of examples, we will make use of something called the EVT, or the extreme value theorem. So to do this, we first of all define critical numbers to be any number C in the domain of F on a closed interval from A to B, where either f prime of C is equal to 0, where the slope is 0, so that would be possibly a maximum or minimum, local or absolute, or if f prime of C does not exist. And so that could be a cusp on a piecewise function. So the extreme value theorem says that if f of x is continuous on the closed interval from A to B, then f of x has at least one absolute maximum and at least one absolute minimum on the closed interval. And what we know is that the only candidates for absolute extrema must occur at a critical number or at an endpoint. So it's going to be important for us to look at our interval, determine what the endpoints are, then look at the function, determine where f prime is either 0 or does not exist, and that gives us a list of possible x values that could be either absolute maxima or minima, and we can investigate each one of those, and that's going to lead us into something called the candidates test. So let's take a look at example 2. So in this example, for each of the function below, they want us to justify why the extreme value theorem can be applied or why it does not apply on the given interval. Alright, so this is a really important part of this theorem, is checking to make sure that the criteria have been met. So taking one more look at this, you'll notice it says if f of x is continuous on the closed interval. So this is the only criterion that has to be checked. So let's take a look at this function and determine whether it's continuous on the closed interval from -4 to +4. And so looking at this function, we immediately see that we have a hole at, actually not a hole, a vertical asymptote at x equals 2. So the function is not continuous on this interval because +2 is on the interval from -4 to 4, and the function is undefined at x equals 2. So at least for this one, I'm going to have to say that the EVT does not apply for f of x on the closed interval from -4 to 4 because f of x is not continuous at x equals 2, which is a point on this interval. Let's take a look at example 2b. So here we have g of x is equal to e to the x minus 2 plus 1. And again, we're on the closed interval from -5 to +5. So are there any values of x that could cause this function to be undefined? And so looking at this, we're taking e and we're raising it to a power. Now we can raise it to a negative power, we can raise it to a positive power, we can raise it to the 0 power, and there's no real number x, especially on this interval, that's going to cause a problem. So in this case, we can make the argument that the extreme value theorem applies for g of x on the closed interval from -5 to 5 because g of x is continuous for all real numbers. Finally, let's take a look at part C. Here we have h of x is equal to x times the square root of x plus 2, and again we're going to be on the interval from -6 to 6 inclusive. So immediately we look at this radical and we realize that we're taking an even root of an expression. Here the radicand is x plus 2, and so This radicand becomes equal to 0 at x equals -2. And there are numbers on our interval that are less than -2. So -3, for instance, would cause this to become an imaginary number. And so at that point, for all values less than x equals -2, this function will cease to exist as a real number. And so we can say that the extreme value theorem does not apply for h of x on the closed interval from -6 to 6 because h of x is continuous only for values of x that are greater than or equal to -2. So this leads us right into the candidates test for finding extrema, and so this will be our approach to solving problems starting with example 3.